In example 4, we've been given a function y equals 3 sine x minus 1, and we've been given this one coordinate here. That coordinate there is at x equals 0.729, or basically 0.73, and y equals 1. Okay, so that's the position given. And it's being asked to find where the other y coordinates are equal to 1 on that graph. So a horizontal line has been drawn at y equals 1. And the first thing we need to establish is what the period is. So based on the b value, in this case the b value is 1, we can establish that the period of this function is 2 pi. So then when we take a look at that first coordinate at 0.73, we know that the next coordinate is going to be over 1 period, okay, or 2 pi. Now the key to this problem is we need to use the symmetry of the graph. And we want to find that green point. So I've labeled the red point as theta 1 and the green point as theta 2. And we're going to use symmetry to find that green position. Now this is related to theta 1 and theta 2 in the circle as well. So there's this symmetry that we're going to use to find that coordinate. So if we take a look at the red dot, we know that it moves from the y-axis 0.73. So that blue line, light blue line, represents a horizontal movement of 0.73 to the right. The symmetry is through the 90-degree point, or pi over 2, and we know it's symmetrical from pi on the right-hand side, and it goes to the same distance backward from pi. Now we could also measure it in this direction. We can measure it to the right and left of that center line. However, because we're trying to find coordinate, it's often easier to work with just the coordinate pi, and then use the position from 0 to 0.73 backwards for that amount. So that angle theta, which I'll call theta 1, that first position, is going to be we're going to start at pi, and we're going to go backwards the angle that was given, because we know that symmetry exists through there. Oops, sorry. That is not going to be that one. That will be the green point, theta 2. So that green position, we're going to start at pi, and we're going to go backwards 0.73. The first coordinate is 0.73. Now, once we establish theta 1 and theta 2, really the other two coordinates are just based on the period. So we're going to use a period from 0.73. We're going to move 2 pi to get to that point there. And so that other angle is going to be 0.73, and we're going to add 1 period, which is 2 pi in this case. And the same can be done with that theta 2, or the green position. We know that's going to move 1 full period. So if we start at the position pi minus 0.73, we add 2 pi, we're going to end up at 3 pi minus 0.73. So the key is then to understand, first of all, the period, and then using the symmetry to get the theta 1 and theta 2 position. The other two angles are just based on coterminal angles, or just adding 1 full period. So here, this example here is essentially the same problem, but we have now a horizontal compression. So now that changes the period. So our period now is at 2 pi over 3. So if I take a look here, we've been given that first green point, and we know that if we want to move between the green points, okay, it's going to be 1 period, or 2 pi over 3. The coordinate given that we start with is at 0.3. So I've drawn that on the x-axis in green at 0.3, and I can move 2 pi over 3 to move between the green points. That blue X represents theta 2. And we can see that if we move 0.3 from the x-axis, so the y-axis, to get to 0.3 in the light blue, as long as we can find the symmetrical point, we know that we can move backwards the same amount. So we have to first establish where that point is. I've drawn that yellow line to show the symmetry, to divide it in half. And if we take a look at this period from 0 to 2 pi over 3, we know that that point here, which I'll mark, this point here, represents halfway, so that must be pi over 3. And then using that position, we can find the blue x point by going backwards the 0.3 that was given at the beginning. So we can see that from the y-axis to the left, to the right, and we can then do that same distance from pi over 3 to the left. So our first angle that was given was 0.3, that's our theta 1. That second angle, using the symmetry, we're going to start at pi over 3, and we're going to go backwards the same amount of 0.3. Once we have those 2 points, represents theta 1 and theta 2. Everything else is just a repetition. And they're going to repeat using the period of 2 pi over 3. So we know that it's going to be 0.3 plus 2 pi over 3. Okay, so that would be the location of that position. It's going to be 0.3 plus 2 pi over 3, which is a period. That's going to be 0.3 plus 2 periods, which is 4 pi over 3. So that's going to be our angle here, plus 4 pi over 3. And then same thing with these positions. That one was pi over 3 minus 0.3. So we add 2 pi, that's going to be pi minus 0.3. And then this is going to be 5 pi over 3 minus 0.3. So I'm just going to write those in. And these again are just repetitions using the period of 2 pi over 3. They're just repetitions or coterminal angles of theta 1 and theta 2.